Okay, so we're going to go through some past HSC questions or some HSC style questions on annuities. So our first question here is the table gives the present value interest factors for an annuity of $1 per period. The various interest rates are a number of time periods n. A man plans to invest $200 each month for 6 years. His investment will earn interest per month at a rate of 9.6% per annum. Based on the information in the table, what is the present value of this annuity? So to work this out, what we need to first do is he's paying monthly payments. That means we need to change our interest rate from per annum to per month. How we do that is our rate will equal 9.6 divided by 12, which will give us 0.8%. Now, if we look up here in our table, the rates up here are all written as a decimal. So we need to change our percentage here to a decimal, which will give us 0.008. The second thing we need to do is determine the number of time periods we have. So n equals 6 times 12, because for every year we've got 12 months, we're going to have 12 different payments. So that's going to equal 72. Now, if we go back up to our table, we find 72, our 0.008. So this is the interest factor that we are interested in. So then we have 54.57097 times the amount of his annuity, which is 200, and that equals $10,914.19. We find that in our multiple choice. There it is. So the correct answer for that question was B. Okay, our next question here, we have a table of future values, future value interest factors as shown. So a certain annuity involves making equal contributions of $25,000 into an account every 6 months for 2 years at an interest rate of 4% per annum. Based on the information provided, what is the future value of this annuity? So to work this one out, again, we need to convert our rate and our number of time periods. So our rate is going to equal 4 divided by 2, which is going to be 2%, and our n equals 2 times 2, because there is 2 lots of 6 months per year, and that will give us 4 time periods. So we look up at our table, we look for our 2%, our 4 time periods, and this is the future value factor we need to take into consideration. So we'll have 25,000 times 4.1216, and that equals 103,040. So the future value of this annuity will be $103,040. Our next question here. Ken invests $200 at the start of each year for 8 years at an interest rate of 5% per annum. Calculate the future value of Ken's investment. Now, it's really important with this one, when you're looking at it, that you read the contribution is made at the beginning of each time period. So this is an annuities table where it's a bit different to the ones we're used to. Most of the annuities tables that we've looked at, the contribution is being made at the end. In this question here, the contribution is actually being made at the beginning of the time period. That one stumped me a little bit at first.
That's why I always read questions carefully.
Part A, so Ken's investing the $200 at the start of each year for 8 years at an interest rate of 5%. So we are looking at our 5% up here and 8 years. So the interest factor that we are looking at is the 10.0265. times 200 equals. So in part A, Ken's invest is $200 at the start of each year for 8 years. So we can say, therefore, Ken's annuity will be worth Ken's annuity will be worth $2,005.30 in 8 years. For part B, we've got Holly. She's planning a holiday in 3 years. She needs $5,000 for this holiday. She's going to make regular quarterly repayments into an account that earns an interest rate of 4% per annum compounded quarterly. What is the minimum investment, the nearest 100 she needs to make to have enough for this holiday? Okay, so B. Our first things we need to do is we need to adjust our rate and we need to adjust our time period. So our rate will be 4%. Now it's compounding quarterly, so we need to divide that by 4. So 1 per quarter, which gives us 1%. The number of time periods is going to be 4 times 3, because there is 4 quarters in every year. So 4 quarters, 3 years. So we're going to have a new time period of 12. Now, looking at our table, we need to find our 1%. So up here's our 1%. We need to go down to 12. So this is the factor that we need to be taking into account here. Now for this one here, because we're trying to find out how much she needs to pay, this is going to be our division question. We're going to do 5,000 divided by our factor. And when we put that in our calculator, we're going to get 390, so $390.34. So we can say, therefore, Holly invest 400. Okay, so Tracy wants an annuity of $15,000 every 3 months for the next 30 years. So her bank's guaranteed an interest rate of 2% per annum compounded quarterly for the life of the annuity. So we want to use the table to find the amount she needs to invest today to provide the annuity. Okay, so what we first need to work out is we need to work out what her interest rate is going to be for the life of her loan. Okay, so we have her rate equals 2%. We now want that to be a quarterly, so we're going to divide that by 4, and that's going to give us 0.5%. We're looking at our number of time periods. So she wants 30 years, and she wants that to be compounded quarterly. So we need to do 30 times 4, which is going to give us 120. So we look in our table. We find our 0.5%. We find our 120. So this is the interest rate factor we need to take into account. So our present value, or PV, is going to equal 15,000 times 90.0735, which gives us so therefore Tracy needs to invest $1,351,102.50. So she will have the total amount that she requires at the end of the 30 years. Okay, our next question here. The table shows the future value of a $1 annuity. This is a future values table. our first question, we want to find the future value of a $5,000 per year annuity at 3% per annum for 6 years with an interest rate compounded yearly. So we don't need to worry about doing anything with our rate. We don't need to worry about doing anything with our time periods. We just need to find our 3% and our 6 years, and this is our interest rate factor. Okay, so we'll have the I, 5,000 times 6.4684, which equals $32,342. So we can say, therefore, the future value is, okay, in part 2 here, we want to know the value of an annuity that would provide a future value of $407,100 after 7 years at 5% per annum. So this is, we've been given the future value, so we've been given that end rate, so we need to find out what the annuity is. So this is going to be one of our division problems. So we want 7 years, 5% per annum. So we look for our 7, our 5%, and we find our interest factor in our table. So we're going to have our 407,100 divided by our interest factor, and that is going to give us $50,000. So they need to invest $50,000 per annum into their annuity to have a future value of $407,100. Okay, part 3. Okay, so we want to find the future value of the annuity. So they're doing $1,000 per quarter at 4% per annum, compounded quarterly for 2 years. Because we're now talking about those quarterlies, that's when we need to start changing our rate. So our rate will become 4% divided by 4, which will now give us 1%. A number of time periods will be 2 times 4, which equals 8. So looking back in our table up here, we're looking at 1% and 8 time periods. So that is our new interest factor. Okay, so now we just put all that into our formula. So we've got our future value will equal 1,000 times 8.2857, which will equal $8,285.70. So the last little bit of this one here is what will be the amount of interest earned. So that's how we actually finish off this question. So we need to do our 8,285.70. So this is to find our interest minus our 1,000 times 8, because we had 8 deposits of the 1,000 over the life of the annuity. So the interest will be $285.70. Question 7 here, we've got a present value table. Mel is 40 years old today and plans to retire when she turns 60. In retirement, she'd like to receive an annual annuity of $60,000 until she turns 90. What single sum should she deposit today in a savings account in order to have an investment large enough to receive her annual annuity in retirement? Assuming an interest rate of 4% per annum for the entire 50 years. Okay, so we're looking at 4%. So we're going to only be focusing on this part of our table here. Okay, so for this one here, we are going to need to do a couple of steps. Our first step is to work out how much money she's going to need into her retirement. So we're looking at from 60 to 90 years. Okay, so the number of time periods is 90 minus 60, which gives us 30. Our rate is 4%. So we go into our table, we find our 30. So what we are looking for is just this value. Okay, so I have 60,000 times 17.2920, and that equals 1037520. Okay, now we need to work out the single amount. Okay, so we're trying to find the single amount to be deposited today. So this one here, we need to think of our compound interest formula. So future value equals present value, 1 plus the rate to the power of n. So we need to think our rate is still our 4%. A number of time periods is going to be our 60 minus 40 this time, which is 20. So our new our new time period will be 20. We plug all of the information that we have into our formula. So our future value needs to be 1,037,520. It's going to equal our present value inside of 1 plus 0.04 to the power of 20. Present value equals so the total amount that she needs to invest will be 473,511 to the nearest dollar. Therefore, Mel needs to invest $473,511 to be able to have the amount she wants in her retirement. Okay, our next question. We're looking at Mark. So Mark needs $8,000 to go on holiday in 3 years' time. He has a holiday savings account with a current balance of $600, and he arranges to deposit $150 into the account at the end of each month for the next 3 years. He's earning 6% per annum interest on the money, and it's compounded on a monthly basis. Okay, so how are we going to work this out? Let's look at our time periods first. So we're looking at 3 years. So n equals 3 times 12, because we have 12 months in a year. That's going to equal 36. Our rate is currently at 6% per annum. Divide that by 12, and we're going to get 0.5%. Our annuity amount, so annuity future value, we're looking at 0.05, 36. So this is our compounding factor we are looking at. So we've got 150 multiplied by 39.3361, and that equals 5,942 cents. Now, our other part of the money, so this balance of 600 that he initially has invested, we look at our compound monthly formula for that. So we're looking at our compound formula. So we're still looking at the same time period and the same rate. So our future value is going to equal our present value, 1 plus r to the power of n. Present value is 600, 1 plus our rate. So remember, with our compound formula, you need to write that as a decimal. So the initial 600 will now be worth $718.01. So the total in his investment will be the annuity plus the compound interest, which will equal $6,618.43. Now he needs to have $8,000 to go on his holiday. So 6618.43 minus 8,000. We're going to end up with a negative number. And so we've got minus 1381.57. So we can say that therefore Mark will not have enough by $1,381.57. Okay, in this question here, we have an amount of $5,000 invested at 10% per annum, compounded 6 monthly. Oh, wait a second. This doesn't look right.
That's because it's compound interest.
That's right. This is not an annuity question. This is just a basic compound interest question. So we approach it in a similar way to how we would do our annuities. So our rate equals 10%. Because we are compounding every 6 months, we need to divide that by 2, which will give us our new interest rate of 5%. Our number of time periods will now be 2 times 3, because it was for 3 years, so we'll end up with 6. So we look at our table, we find our 5 and our 6. So this is the compound interest factor that we are looking at. So we'll have 5,000 times 1.340, which will give us 6,700. So we can say, therefore, the investment is worth 6,700 in 3 years. Excellent. Okay, looking at our next question. So this question here, we have 2 people. We've got Lucas and Ethan. They are both investing money at different types of things. So Luca is just investing a lump sum, whereas Ethan is investing an annuity. So we need to work out how much each of them earn. So Lucas, here's our compound interest. Remember, that's future value equals present value 1 plus r to the n. Now he is at a rate of 6% per annum. 6% per annum compounded annually. So we don't need to worry about changing our rate or our number of time periods. So our rate is our 6% and our n is our 5 years. So we put it all in. Future value equals 80,000. 1 plus 0.06 to the power of 5. In our calculator, that will come out as 107,058.05. So his financial gain, because what we're trying to find out is who actually is gaining the most money here. His financial gain will be 107,058.05 minus the $27,058.05. So that's Lucas finished. Ethan, he is our annuity. So he's doing regular repayments. So he's a little bit different. So he's doing that at the end of each month for 5 years. So we do need to change some things around for Ethan. So our rate is going to be 6 divided by 12, which equals 0.5%. And our number of time periods is going to be 5 times 12, which equals 60. So we look in our table, we find our 0.5%, and we find our 60 time periods. And we put that into our future value. 2,500 times 69.770. and we get 1,700 and 4,425. So again, we want his financial gain. So he's made 6 payments of the 2,500. So his total gain is 24,425. Now we want to know what the difference is. So the last thing we need to do is just work out the difference. So for 27,005 minus 24,425, which equals $2,633.05. So we can say, therefore, Luca had the best financial gain by $2,633.05. Okay, Sally is currently age 50 and is planning to retire at the end of the year. When she turns 60, self-managed super fund has $530,000 and is delivering 3.2% compound interest. So she's making a payment. It's asking us to determine what the payment is. So how much is she increasing her payments by? So to do that, what we do is we find our two values up here. So we use these two values. There's lots of ways to do it. This is how I find the easiest. So you have 8772 divided by 8600. That equals 1.02. So from this we can say, therefore, n equals 2%. So between each of our time periods, we're increasing by 2% on the previous time period. To find the values of A and B, so for A, what we are doing is we have our balance of our annuity plus the payment received. So we'll have 914,785.93 plus 10.06.88. We're going to be multiplying this by our rate, which is 0.032, and that equals 29,622.17. Our value of B, that will be 194. So the balance at the end of the previous year plus our repayment plus the interest that we've earned. So our value for B will be 928,654.98. Okay, so Sally has decided to delay her retirement for another year. So we want to know what her contribution payment is going to be. So how we work that out is we do 11347.52 times 1.02, because remember it's increasing by that 2% each year. So that's going to equal $11,574.47. What will be the new balance of the annuity at the end of her 66th year? Okay, so to work this one out, so I'm just going to do this one down here. How we do it is we do her balance at the end, so this value over here at the end, so 1040992.42 plus our contribution amount, so 11,574.47. We're going to multiply all of that by 1.032 because it's increasing by 3.2% per year. So her balance at the end will be $1,086,249.03. Okay, so Oscar's planning to invest some $200 each month for 74 months, and his investment rate is the 0.008. We've got 74 months. Our interest factor table up here is already in decimals, so this is the interest factor that we're interested in. So we can say his present value will equal 200 times 5, 6, 4, 4, 6, and that will equal $11,136.89. So therefore, the present value is $11,136.89. Okay, so that was part 1. Now we're going to look at part 2. So Lucy is using the same table to calculate her loan repayments for her car. So she's bought a car. The loan is $21,500. She needs to make equal monthly repayments over the next 6 years. So first off, we need to change our rate. So we have 10.8. Because we're now doing monthly, we need to divide that by 12, which will give us a new percentage of 0.09%. Now, because our table is in a decimal form, we need to convert this to a decimal, so that will be 0.009. A number of time periods, we have 6 years, 12 months, so we're going to have 72 months as our time periods. Okay, so her loan is the $21,500. Because we want to know what her monthly repayment is, we need to divide that by our value in our table. So we have our 0.09, we're looking at 72, so that is our interest factor we're interested in. So we will divide this by 52.82118. That will give us a value of $407.03. So we can say, therefore, monthly repayment of $407 to nearest dollar. Okay, so our table is giving us our contribution per period of an annuity with a future value of $1. So Margaret needs to save $75,000 over 6 years for a deposit on a new apartment. She makes regular quarterly contributions into her investment. How much should she be paying? So we're talking about quarterly investment. So this is important. So it means we need to change our time period and our interest rate into quarters. So our rate is going to equal 3 divided by 4, which equals 0.75%. Our number of time periods is going to be 6 times 4, which equals 24. So we look into our table, we find our 0.75%, we find our 24, and that gives us what our interest factor is going to be. The contribution factor is going to be. So our contribution is going to be 75,000 times 0.0382, and that equals $2,865. So therefore, Margaret needs to make monthly payments of $2,865. Okay, here we have another table of future value interest factors. So part 1, we have an annuity involves contributions of $12,000 per annum for 5 years. The interest rate is 4% per annum, compounded annually. So we are just looking at simple. We look for our 5 years, our 4%. That's our interest factor that we're after. So we do 12,000 times 5.4 163, and that equals $64,995.60. So we can say, therefore, future value is $64,995.60. In part 2, it is asking us how much interest is earned. So our interest is going to equal the final value minus all of our payments. So over the 5 years, we've made 5 repayments. So we're going to end up with $4,995.60 in interest. So I can say, therefore, interest earned is $4,995.60. This one here, Ali's making monthly deposits of $100 into an annuity over 5 years. Calculate the total amount she's deposited. So this one here is just looking at her deposits, which is 100 times 5 years times every month, which equals 6,000. Therefore, total deposits, $6,000. Okay, our table here shows the future values of an annuity at different interest rates. So an annuity is opened and the contributions of $2,000 are made at the end of each year for 7 years. For the first 6 years, the interest rate is 4% per annum compounded annually, and in the 7th year, the interest rate increases to 5% per annum compounded annually. So we actually need to approach this one in a couple of different steps. So we need to first find out how much it is over the first 6 years. So we are looking at our 4% 6 years. So this is the interest factor we're after here. So we do our 2,000 times 6.633. So therefore, 13,266 is value of annuity at end of 6 years. So that's the first part of our question. So this bit here is done. Now we need to focus on the 7th year. Now we need to look at compound interest for our 7th year. So compound interest, so that is our future value equals present value 1 plus r to the power of n. Our future value equals our present value of our annuity is $13,266. Our rate is 1 plus 0.05 because we're now looking at our rate over here as being 5% per annum. And that is just to the power of 1 because we're only going for the 1 year. So that will give us $13,929.30. So our future value, so our value of our annuity, our value up here, plus our final repayment. Because remember with annuities, the payment always comes at the end. So at the end of that 7th year, they will deposit another $2,000 into the account, bringing the total in the account to $15,929.30.